Okay. On the first one, like I said, this first page I thought was going to be better. What you had to do with these problems, guys, is you had to simplify your ratios. So, and the other thing that was a little bit of a curveball with this first question, which I did not take points off for, is if you noticed in the questions they reverse it. Student to teacher ratio. Did you notice that the first sentence had teachers to students, and then they flipped it? Okay, I didn't take off points if you reversed it, but I did take off points if you didn't simplify it. So what you had to do is you have 36 to 6. What number goes into both? Raise your hand. You divide both sides of the quantities by 6, and you wind up with 6 to 1, and that got you full credit. Okay? If you didn't reduce it, or you reduced it and didn't reduce it all the way, I took off half credit. Question on it? Yeah. Good. If you flip-flopped it, I still gave you credit because I thought I didn't want the question to confuse you by reversing it. And as a matter of fact, I've changed it for next year because I think you have enough to do with realizing you got to get the ratio and then you've got to simplify it. Okay, next one. 90 cartons of orange juice is put out and 27 remained. You have to do a little bit of subtraction with this. So when you come to the first question, they're asking juice cartons taken to the total. How do you figure out how many are taken? What do you have to do? Sage. What should you do? Back. You got to do that first. You'll wind up with 63, and now you can create your ratio. The total is going to be 90. I'm sorry, it's 90 take away 63, right? And that gets you 90 take away 27. Gets you 63 to 90, okay? Then you got to reduce it. What number goes into both? And I realize divisibility is still an issue with you guys, okay? Because you're not readily seeing that there is a number that goes into both. What number goes into both? 9 goes into both. If you did 3, you could do 3, and then you got to do 3 again. If you divide top and bottom by 9, you wind up with your simplified 7 to 10, and that's your answer. Okay, then we've got remaining to taken. Remaining we've already figured out. Remaining was 27. And taken we've already figured out as 63. 27 is up here. What do you need? I got to take a look at it afterwards. So now we have 27 over 63. What number goes into both? Come on, what number goes into both? Alyssa. 9 goes into both. You wind up with 3 to 7. Full credit, okay? I still want you guys getting into the habit of whenever there's a word problem, pick out your VIPs and get your gist. Some of you are kind of getting away from that. So when you come to this first word problem, we have VIPs in the first sentence. It's an 8-gallon ratio to 176. I'm going to write it down. 8 to 176. What I think is also helpful that you're going to see more and more is something called a template. The 8 is representing what measurement? 8 what? Ava? 8 gallons. I'm going to put that to the left, just so we know what's what. 176 represents what?
Miles.
That's the bottom part of our ratio. Now I know that gallons is on top and miles is on the bottom. When I take this next ratio, I know what's supposed to go where. 22 miles. Miles we've established as bottom. I'm going to put it at the bottom. And 1 gallon. Now we're still not sure whether they're equivalent or not. They're asking us to figure out if they are. That's our question, right? How do you do it? We did it back in the first 5 or 6 lessons, and some of you forgot how to do it. Spence, good.
5, 8, and 176.
Okay, so you realize as you go from here to here, you're actually dividing by 8. Or if you're going this way, you're multiplying by 8. So you know 1 times 8 is 8. That's good to go. What you have to figure out is whether if 22 times 8 is 176. Is it? It is. So the answer is yes. Where you got hung up was the word constant. My fault, because I haven't taught it in about 3 or 4 weeks. The constant is the number that you're multiplying by when you create your equivalent ratio. Okay? So the constant is 8. All right? Let's move on. Tape diagrams again. You get used to seeing it on every test in ratios because you're going to see it on the state exam as well. It was on the state exam last year. Same thing. Pick out your VIPs. Look at what you need. You got 2 to 6. This becomes a key important VIP. And then this is a gist, what you're really trying to find at the end. Now, the way it worked out point-wise, if you created a complete and correct tape diagram, it was worth 2 out of 6 points. So I don't care what you use for abbreviations. I'm going to use athletes to non-athletes. Some of you put down other abbreviations as long as you put something. And that is a tape diagram of 2 to 6. And that's coming directly from the VIP up above. Okay? Spence. Yeah, if you flip it, that's okay too, as long as you stay consistent. The tape diagram is always, always, always the given ratio. However, I will tell you this. If you wanted to, you can take 2 to 6 and reduce it to 1 to 3, and it would still work. Okay? Because it's an equivalent ratio. But I'm just saying, take what they give you, 2 to 6, as long as the numbers are not crazy. Like, if it's 10 to 90, you could reduce that to 1 to 9 and be able to do a tape diagram, 1 box to 9 boxes. You don't want to do 10 boxes to 90 boxes. It would take forever. But 2 to 6 is manageable. Yeah. All right, next thing. It's a difference question. What keywords, as a matter of fact, we put it in bold. What keywords in the bold-faced print indicate that this is a difference question? Alexis. More and what? More and one other keyword. More and than. I have 5 more than you indicates difference. So you say to yourself, okay, let me look at, remember, this is a model, this tape diagram. How many more boxes are there of non-student athletes to student athletes? How many more boxes are there? Cookie. There are 4. I'm going to put a bracket around it. Those 4 extra boxes are representing the 8 students. So I got to take the 8 and divide it by 4, and that's going to give me my magic number of, say it out loud, 2. Once I have 2 for these boxes, it's good for every box. MKV. Yep, you can do that. You realize that that's the difference. Now here's the question. The gist is asking us for total. That's everybody in the entire class. Either add up all the boxes or do 2 times 8 for 16. All right? All right, the equivalency ratio table was not bad. I was generally pleased with that. You see that you're counting by 9s here. Once you have this 15, that now establishes a counting pattern in that column as counting by 15s. And that was fine. I'm not going to go over the tape diagram simply because we don't have time and it's a bonus anyway. But in case you're curious, the answer wound up being 24. And I will be honest with you, there is an easier way to have figured this out other than a double tape diagram. Because if you could find the value of the ratio, which is 3 to 5, watch this. 3, top is pages, bottom is minutes. How many pages, the unknown, will you read in 40 minutes? 5 times what makes 40? 8 times 3 is? Done. That's why I don't want to spend time going over double tape diagrams, because as we finish this unit, there are so many other strategies that you can use that just simply work better. That's kind of why I made it as a bonus. Alexa. It wound up being just a bonus. If you got it wrong, it didn't count against you. MKV. I am not putting double line diagram on the makeup. I'm taking it out. I know. That's why you should have used a double line diagram according to the question. I'm not going to show you how to do it now because it takes too much time. I'm just trying to explain why I made it a bonus and why I think there's a better way to do it. Back. I know. I know. I don't think it was a great question. How's that? That's why I didn't count it against you. There are some instances where a double line diagram can come in handy. That's not one of them. But it's on there because it's on Common Core, and I got to at least expose you to it. This, however, this next page, you kind of got to know. The best advice I can give to you is whenever you come up with an equation, or you choose an equation, or if you make an equation, you've got to test it to see if it works. Many of you didn't do it. So I'm going to show you the process again of how to test your equation. Here you had to choose A, B, C, or D. What you should have done is substitute values for each one until you get an equation that works. So I'm going to take this first one, and I need you guys to do this on your test if you didn't do it. Write down the first equation. I am going to choose the second column here, second row. Christian, in the second row, what's the value for C? In the second row, bud. Look again. We're looking at this row. What's your value for C? Okay, watch. I'm going to substitute my 2 in for C. My 4 is my constant, because that never changes. Christian, what's my value for T? Okay. You got it? Now, look at the statement. Are those two quantities the same? Is 2 the same as 4 times 8? Christian? Is 2 equal to the same as 4 times 8? What's 4 times 8? 32 is not equal to 2, bud. Can't be A. Dave Longley. Let's do B. Same row. What's the value for t, Dave? Look again. You got to look at your table. In the row that I've indicated, what's your value for t in the row that I've circled in blue? Very good. I'm going to substitute it in. Times, what's my value for c in that same row? Dave, when you're ready. Now watch what I'm going to do, which is a hang-up for you guys, I know, because it's multiplication of fractions. Here's how we multiply fractions together. 1 times 2 is? 4 times 1 is? Is 2/4 the same number as 8? It is not this. Let's take choice C. T equals 4 times C. Remember, when you see a number and a letter together, it means to multiply. Spence, same row. What's the value for T? What's the value for C? Is the statement true? We have a winner. That is our answer. You've got to test it every single time. You had to do that with the next one also. I'm going to show you what the wrong answer is for this, and I'm going to show you how testing is going to prove why it's wrong. Don't write it down. I had a lot of students that realized when they looked at this. Now we're looking at cardinals and sparrows. I'll do it in red. Cardinals and sparrows. A lot of you realized that there was some kind of relationship going on with 3. So when you came up with your equation, I saw this. And I'm going to write it down here. C equals 3s. Test it. I'll pick a different column just so I could show you it with a different column. Let's choose the last. Ryan, value for C in the last row. Value for S. Is 4 the same as 3 times 12? Right? What's 3 times 12? $36. Is 36? Well, that one I can live with. 36 equal to 4? Can't be this equation. No good. However, do this. Many of you realize something's going on with 3. If you get it, after you've tested it, you realize you're not getting equal quantities, flip the letters and make it S equals 3C. Let's test it. Ryan, I'm going back to you again, because you got me a little worried back there. Ryan, value for S, bud. Okay. Value for C. I won't scroll up, but look on your sheet. All right, let's try this again. What's 3 times 4? 3 times 4 is 12 equal to 12. Is 12 equal to 12? We now have an equation that works. That's our answer. Okay? All right, let's move on. All right, second to last page. Most of you guys were good with the value of the ratio table, which is 1 to 6. If you put 2 to 12, I had to take off half credit because that's not the value. Read the directions very carefully. Okay, same thing with the equation. You realize that there was something going on with the multiplication of 6. You just had to make sure that your letters were arranged correctly. Think of it this way. What are we doing to this number, h? What are we doing to h to get m? So 6 times h, or 6h, is equaling m. Test it. Once you get it, test it. 6 times 2, in this case, that's our value for h, is supposed to equal the value for m, which is 12, and it does. So this is correct. Brandon. It will also work. I'm trying to keep it simple with multiplication and not dealing with fractions, but as long as, if you came up with a division one, or one that was a multiplication of a fraction, as long as you test it and it works, you're fine. Cookie. You're okay. You can do that. Because watch, if you test it, it will work. If it tests out and it works, it is correct. Siege. Later. Ryan. Yeah, the only thing that I would do is you always put the constant first before the variable, but I still gave you credit. Okay, you are fine with this. The only, and I'm gonna, because we're running out of time, I gotta get to the last page. The only thing that I want you to be conscious of this, I'm not gonna go over this, but look. Not only is it 4 points if you label everything, but you need to put a label for each axis and create a title. Those are careless errors. That's 6 points. If you didn't put miles and hours or distance, that's fine. Just make a note, guys. Many of you reversed it. Time is always on the bottom. Okay, so listen, read the directions carefully because you don't want to throw away points that are unnecessary. That's 6 points just because you didn't label your axes or made a title. R squared. As long as it's on the bottom, you're okay.
I'm okay with that, but I lost points on the
No, not the XY. What this is representing. This is representing your hours. This is your miles. That's what we mean. So, but now you know for when you take it again, if you want to take it again. Okay, last page. Many of you were fine with E. The answer was no. Many of you realize that in 8 hours it would be 48 miles. I'm just going to kind of do that in shorthand because I want to get to the lemonade one again, which some of you are still having trouble with. All right, the lemonade one. You cannot figure out what's what by looking at the ratios as they are. You can't look at the value of the ratio. You can't look at this and determine whose recipe is stronger. You just can't. What you've got to do is you've got 2 strategies. The first one is see where you can compare lemon juice to lemon juice that are the same. And you have it. You have a 6 to 10 and you have a 6 to 9. If the lemon juice is the same, then the recipe that has less water is stronger. That's going to make this stronger. That's strategy 1. Yeah, Siege. What'd you do? I'll get to it in 1 minute.
I didn't do 66, but I did 4 and 12.
Alright, so that's actually a third way, but let me show you another way you can do it. I can extend the table for Gene. I'm counting by 2s. I'm going to continue to count by 2s. 2, 4, 6, 8, 10. This is counting by 3s. That's going to make 10 and 15. I now have an equivalent ratio that matches up water. Therefore, more mix, stronger recipe. Spence's way, equivalent ratio. He took his 4 to 6, I think, and you made this. What did you make this? What did you do? Tell me what you did.
I matched the 4 to 12.
Here, right? Okay, so you made this as an equivalent ratio. You did this as 12 to 18, I think, because now you have equal amounts of juice, lemon juice. This still has less water. 18 is less than 20, so this is stronger still. Siege, what'd you do? Yeah, so essentially what you did is you took your given ratios and you made these ratios, this 10 to 15 and 9 to 15, which is already given. All right. All right. I think we're good for.